Hello. Today, we're going to dive into some new trigonometric functions. We'll be building on your knowledge of sine and cosine to understand their reciprocals. By the end of this video, you will be able to identify key characteristics of the secant, cosecant, and cotangent functions, including their domains, ranges, and asymptotes. So, let's get started. First up is the secant function. The secant of theta, written as secant theta, is simply the reciprocal of the cosine of theta. This means that to find the secant of any angle, we just calculate the cosine of that angle and then flip it. So, we can say that f of theta equals secant theta, which is equivalent to writing f of theta equals 1 over the cosine of theta. Now, whenever we have a fraction, we have to be careful about division by 0. For secant theta to be defined, the denominator cosine theta cannot be 0. Therefore, the domain of the secant function is all real numbers except for the values of theta, where cosine theta equals 0. These values occur at pi over 2, 3 pi over 2, 5 pi over 2, and so on. In general, we can write this as theta cannot be equal to pi over 2 plus k times pi, where k is any integer. These values create vertical asymptotes in the graph. Remember, an asymptote is a line that the function's graph gets arbitrarily close to, but never actually touches. To find the range, or the set of possible output values for secant, let's consider the range of cosine. The range of cosine theta is between -1 and 1, inclusive. Since secant is the reciprocal, what happens to its values? If cosine theta is 1, secant theta is 1 over 1, which is 1. If cosine theta is -1, secant theta is 1 over -1, which is -1. But if cosine theta is between -1 and 1, what happens? For example, if cosine theta is 0.5, secant theta is 1 over 0.5, which is 2. Notice that the absolute value increased. This means that the secant function will have a range that is all values greater than or equal to 1, or less than or equal to -1. In interval notation, this is -infinity to -1, union 1 to infinity. So, in summary for secant, we have that secant theta is 1 over cosine theta. The domain excludes angles where cosine is 0, and the range excludes all values between -1 and 1. Let's move on to the cosecant function. The cosecant of theta, written as CSC theta, is the reciprocal of the sine of theta. Just like with secant, this means to find cosecant, we find sine, and then flip it. So we have f of theta equals cosecant theta, which is the same as f of theta equals 1 over sine theta. Again, we have a denominator, so we must make sure it's not 0. This means sine theta cannot be 0. The domain of cosecant is all real numbers except for the values of theta, where sine theta equals 0. These values occur at 0, pi, 2 pi, and so on. We can write this as theta cannot be equal to k times pi, where k is any integer. Similar to secant, these exclusions are the locations of the vertical asymptotes for the cosecant graph. Now let's consider the range. The range of sine theta is also between -1 and 1. Just like with secant, taking the reciprocal will expand this range. If sine theta is 1, cosecant theta is 1 over 1, which is 1. If sine theta is -1, cosecant theta is 1 over -1, which is -1. And for any value of sine between 0 and 1, like 0.25, cosecant will be 1 over 0.25, which is 4. The values grow larger in magnitude. So, the range of the cosecant function is the same as the secant function, all values less than or equal to -1, or greater than or equal to 1. In interval notation, this is -infinity to -1, union 1 to infinity. To recap for cosecant, CSC theta is 1 over sine theta. Its domain excludes angles that are multiples of pi, and its range is identical to that of the secant function. Finally, let's talk about the cotangent function. The cotangent of theta, cot theta, is the reciprocal of the tangent function. We also know that tangent theta is sine theta divided by cosine theta. So if cotangent is 1 over tangent, that means it's 1 divided by sine theta over cosine theta. This simplifies to cosine theta over sine theta. This is a very important identity to remember. Cotangent is the ratio of cosine to sine. So, we have f of theta equals cotangent theta, which is equal to cosine theta over sine theta. Because cotangent is a fraction with sine in the denominator, its domain restrictions are the same as cosecants. The domain of cotangent theta is all real numbers except where sine theta is 0. So theta cannot be any multiple of pi. These values are where the vertical asymptotes of the cotangent graph occur. Now let's consider the range. As theta moves from one asymptote to the next, the value of cotangent starts at positive infinity, decreases, passes through 0 when cosine is 0, and continues all the way down to negative infinity. Think about it. As sine gets very small and positive, like near x equals sine 0, cosine is close to 1, making cotangent very large and positive. As sine approaches 0 from the negative side, cosine is close to -1, making cotangent very large and negative. Therefore, the range of the cotangent function is all real numbers, from negative infinity to positive infinity. In summary, cotangent theta is cosine over sine, its domain is the same as cosecants, excluding multiples of pi, and its range is all real numbers. Let's summarize the key characteristics we've discussed for these three new functions. First, the secant function, sec theta, its domain is all real numbers except for odd multiples of pi over 2. Its range is the set of all numbers with an absolute value greater than or equal to 1. And it has vertical asymptotes at x equals pi over 2 plus k pi. Next, the cosecant function, csc theta. Its domain is all real numbers except for multiples of pi. Its range is also the set of all numbers with an absolute value greater than or equal to 1. And it has vertical asymptotes at x equals k pi. And finally, the cotangent function, cot theta. Its domain is all real numbers except for multiples of pi. Its range is all real numbers, from negative infinity to positive infinity. And it has vertical asymptotes at x equals k pi. As you can see, the domain and asymptotes of cosecant and cotangent are the same, because they both involve sine theta in the denominator. The key difference is in their ranges. You should now be able to define the secant, cosecant, and cotangent functions and identify their domains, ranges, and vertical asymptotes. Thanks for watching.